Alright, this is probingDAC, which is my final project for CMC on the audio side. So for this project I explored the discrete audio codec latent space and treating it as an effect or something like that. I'm plotting heat maps of the latent space and see what's interesting in there. So for starters, I plotted silence, sine, and noise. This is this is silence, which is as expected is constant, but it's not zero. So the zero in the latent space is not silence. This is noise, which as expected is random, and it's very big. The vectors are very big for some reason, which I don't know. And the sine shows some windowing, because of the windowing has some periodic things happening. If we plot very quickly this one, which is a 64 sample basically wavelength, it's constant. All right. Then I tried to measure the distance, the average distance from silence of various signs based on frequency, and there is some trend, not really relevant, I think. Here there's this bump, which is interesting, I think, might be related to the fact that it's trained a lot on spoken voice, and this is a very important place for spoken voice. But I don't know, maybe it's just random. About amplitude, it's quite interesting. We can see that there's a clear trend. It's almost linear with the dBs. So yeah, the size of the vectors, it's in some way seems to be, at least in the case of science, it seems to be linked to the loudness. Then I did some creative decoding. So basically drawing in the latent space and see what comes out. So starting from silence, I added the one dimension noise from noise. And it's kind of interesting textures. Of course, you can add more and tweak a little bit, make one bigger, one faster. And yeah, I think it's a nice synthesizer. It could be fun to have faders and play in real time with this. Could be very organic textures and crackles. Then I tried some distortion in the latent space. I discovered that if we amplify every dimension, nothing happens. The sound is the same. But if we amplify just a few dimensions, there is this distortion, which also might look symmetric. Not sure. And yeah, with a 200 Hertz, sounds like this. This is of course a sine, and this is the distortion. So the pitch is kept, but it's more organic, more machine-like. Very interesting, I think. Could be useful as an effect. It's quite cool. I want to try it on other instruments, and voice. Then I started to, since I've noticed these periodic patterns here, I started to try to reproduce them in ways, try to make pitched sounds. So I started with this, with just lots of sines at increasing frequencies. And you can see clearly that's looping, but it sounds like this, very unexpectedly. It sounds like a robotic voice. Interesting. Probably this is too messy. I tried this one, which is just shifting the phase of the sines, and this sounds much more as expected. It's kind of filtering, so it's pitched and it's kind of filtering. I think it's pitched around one of the harmonics of the window. quite cool if you ask me. Maybe superimposing those patterns to sounds can lead to interesting results. And then I did some random signs to see if something cool happens, and the result is no. This sounds much more like a random walk in the latent space. It's just this, I would call it like the DAC sound. It's very similar how DAC sounds if you're in random places, but still quite a particular sound. And yeah, this is it. There's a big document that goes more in depth, and the code is on GitHub.